Good morning, everyone. Today, we are present here to brief our research work on the topic IoT based weapons detection system for surveillance and security using YOLO V4. The unique idea of object detection actually starts in 2001 by Voila Jones detectors, developed by Paul Voila and Michael Jones. This object detection framework allows the detection of human faces in real time. It uses sliding window to go through all possible locations and scales in an image to see if any window contains a human face. Then comes the histogram of oriented gradients, sometimes referred as HOG detector. It was developed in 2005 by N. Dalal and B. Triggs. It works with blocks. A dense pixel grid is which gradients are constituted from a magnitude and direction of change in the intensities of pixel within block. Then came the CNN, which is known as Convolutional Neural Network, in 2012, and it was later changed to RCNN because a faster algorithm came, which used linear SVM classifier. Its full form is Support Vector Machine to predict the presence of an object. Then comes YOLO algorithm in 2015. All the previous object detection algorithms use regions to localize the object within image, whereas YOLO trains on full images and directly optimizes detection performance. We all are living in a society where security is the major concern, and due to increase in crime and terrorism, security surveillance is becoming increasingly important. And to solve this, we have come up with the idea of IoT based weapon detection system for surveillance and security using YOLO V4. On a daily basis, we saw so many articles in newspaper and social media regarding robbery and murder, and these things become our motivation to develop something like this to contribute to the society. Use of this type of technology reduces human efforts and provides efficiency. We basically developed the detector such that it is able to recognize all different types of weapon which can be used for threatening people. It will detect and alert the respective authority about the threat. It is able to work in different visual conditions, such as in dark night or low image quality. In this example, we can see a real life situation in which a thief is holding a gun towards jewelry shop owner and trying to steal the money and other valuables. To handle this, our detector would detect weapons in the fastest pace and would inform the nearest police station. And now my colleague will take over.
Let's talk about architecture. YOLO V4 is an one-stage detector as it skips the part of region-based proportion and directly works over the sample in possible locations. It has three components: a head, a neck, and a backbone. Head is used for calculating losses and for the prediction part, whereas backbone is used for feature extraction, which means it manages the data and convert or combine to form the beneficial data for the training part, whereas neck is used for enhancing the quality and representation of extracted features which is which is formed during backbone. Backbone contains CSP Darkman 52, which is a convolutional neural network used in YOLO detector. There are two types of optimization method used in YOLO V4, which are bag of freebies, which could make better accuracy without increasing the inference cost, and bag of special, which can increase the inference cost by a small amount but can drastically improve the accuracy. Bag of freebies and bag of special contains some augmentation and regularization, normalization and some activation techniques. Bag of freebies is used for during training part and bag of specials is used during inference part, which is the testing part. Now some features and YOLO V4 has been upgrading since its born. YOLO, YOLO V2, YOLO V3, YOLO V4 and now even YOLO V5 is available. As the version increases, the MAP, mean average precision, of its also increased. Its neural network can be easily installed in any system, even having a single GPU. Camera. Camera also plays an important role in the whole project, as the more pixel the camera have, the more is the clarity of an image it will provide for the detection, and it faster will be the detection. Sensors have the dominant role in IoT devices, as it does the most important job for improvising any model. Sensors are, for example, if the weapon is inside body or under a cover, one can use heat sensor or ultrasonic sensor to identify the object or the target easily. Wireless modules will also be the part of it, as for sending alert system we needed wireless module which can contact a target point wirelessly in a range of different fields. Now the implementation part. We used Kaggle We have used Kaggle label dataset and labeled some of our own custom images and use them in training and validation process. As the dataset is divided into two parts. One is for training the neural network and one for validating it to the another. To calculate the loss and change the values according to it in its neural nodes. MAP, mean average precision, is used for metric efficiency calculation. For checking the efficiency of a model, we have used 416 into 416 pixel size images for training, as a fixed size image will help the faster learning of a neural network. We also use data augmentation, such as we have cropped images, flipped or mirrored images, reversed images, so that a model could identify the target even in any condition it comes. We have trained our model with 3000 iterations or rounds of training loop. We have configured the system during training part with 64 batches and 16 subdivisions, which means it will train 4 images per batch. And during testing part, we have changed it to the one batch and one division, which means it will test one image or a one video at a time. Now let's talk about the results. After training a model, we tested it on images as well as videos, and the results are satisfactory. In above image, the gun which is away from the view is detected with 0.96 accuracy, which is a short one, and the gun same color as its background of jacket of a thief also got detected with 0.76 accuracy. which is a pistol. If it performs the region based, the accuracy rate may more less as the region of gun and the jacket of the thief would be similar of the detector. Now we have tested it on a multi-weapon image where it detected all 11 guns and pistols with highest accuracy of 99% and lowest accuracy of 54%. We have tested it on a night vision video where it detected the weapon with accuracy of 82%. Our model's MAP is 77.75 with average loss of 1.314. We trained it with 2500 plus images and only trained for 3000 iterations. In such low data set and less number of iterations, it have given satisfactory results. So it can get up to more MAP if more data set and more iteration provided. Here are some. Our conclusion is a YOLO V4 is model is efficient. It will give high results in real-time scenario as it is fast and can be used in a single GPU system. With high time for training and large dataset will give more accuracy and MAP. When connected to IoT devices, it will become a smart AI device and can be used in a CCTV camera system. Here are some references research papers which we have looked and studied for our research work. Thank you.